concepts of limits. Okay, first notation: limit x approaches e of fx equals to e. X approaches number of e of a function fx equals to L. L is the limits of the function. L here represent any function, linear, quadratic, or the cubic function. In the second notation, limit x a approaches e from the left of the function fx, and here equals to the L. Okay, second notations, this minus sign means limits as x here approaches a from the left of the function. So when you draw the number line here, when a here equals 2, yeah. Okay, so find the left-hand limit of the function, LHL. Write down the limits as x here approaches 2, and the minus sign from the left of the function of fx, and here equals to the L, yeah. And the second part of the function here, x approaches a from the right of the function. This positive signs means limit as x here approaches a from the right of the function, and equals to the L, yeah. Examples: when the value of a here equals to the 4, and draw the number line. Okay, so here find the right hand limit of the function, RHL, and write down the notation: limit as x here approaches 4, and positive sign here means from the right of the function of fx, and here equals to the L, yeah. Okay, first using a graphical method to find the limits of the functions. Here the example of the graph of the rational function. We can see what happened around the point x equals 2, and when you find the limit of fx, you have to check the both sides of the x equals 2, from the left of this function, from here, and from the right of the function, start from here, yeah. So from the left of the function, you start at the 1. Start from here at 1, 1.2, 1.5, 1.9, 1.99, 1.999, really close to x equals 2. From the left of the function, and checks the y values on the y-axis. So the y values here equals to the 4. Okay, so the left hand limit of the function, limit as x here approaches 2 from the left of the function fx, and here equals to the 4. Okay, and find the right hand limit of the function. Okay, so start from the x equals to the 4, 3, 2.5, 2.1, 2.01, 2.001, and really close to x equals 2 from the right of the function, and then check the vertical value on the y-axis. So y here equals to 4, and write down notation, limit as x here approaches 2 from the right of the function, and equals to 4. Yeah. And then limits approaching the same value from the both side of the function. From the left here, limit equals to the 4, and from the right here, limits of these functions equals to the 4. Okay, and the conclusion, limits of fx here exist. Okay, limit as x approaches 2 of fx here exists, and equals to 4. Okay, and question A, find the left hand limit of the function. So sign here minus, negative. So here from the left, and question B, limit as x here approaches 1 from the right of the function. Okay. Here example of the graph of the piecewise function. First graph here, this function only defined when x here greater than or equals to 1, and the second part of this function only defined when the value of x here less than 1. If you want to find the limit of fx, you check from the both sides of the function. From the left, start from here, negative infinity to x equals to 1, and then from the right of the function, positive infinity to the x equals to 1. Okay. So from the left of this function, we start here, negative 2, negative 1, x here equal to 0, and 1.1, 1.01, 1.001, really close to 1, not 0.9, 0.999, and 0.999, really close to 1, and the left hand limit here equals to the 1. Yeah, you check the y values. Okay, write down the notation. Left hand limit as x here approaches 1 of fx, and answer here equals to 1. Yeah. And find the right hand limit of the function between negative infinity and x equals to 1. So we start from here. Okay, start at the 4, x here equals 3, 2, 1.5, 1.1, 1.01, 1.001, approaching 1 and really close to 1, and the checks y values on the vertical axis, and y values here equals 2. Okay, and write down notation. Limit as x here approaches 1 from the right of the function, and here equals 2. If you compare the left hand limit and the right hand limit of the function, limit as x here approaches 1 from the left of the function, and limit as x here approaches 1 from the right of the function. From the left of this function, left hand limit here equals to 1, and from the right of the function, right hand limit here equals to 2. Okay, so left hand limit and the right hand limit here are not the same, so here you put the not equals. Okay, and the limit of fx here does not exist. Okay, limit as x approaches 1 of fx here does not exist because it's approaching the difference value from the both sides of the function. Okay, from the left here 1, and from the right here equals to 2. Okay, second method to find the existence of limit. So fx here equals to the x squared minus 4 over x minus 2. Yeah, so find the left hand limit of the function. So start from here, from the left. Substitute the value of x 1.9, and the y here equals to the 3.9. Second value 1.99, y here equals to the 3.99, and then here 1.9999, and the y here equals to the 3.9999. We will see this function is approaching 4 from the left hand side of the function. Okay, so from the table here, write down the limit as x here approaches 2 of x squared minus 4 over x minus 2, and here equals to 4. So here from the left of the function, left hand limit. Okay, and the right hand limits start at the 2.1, the nearest value, and substitute into the function. Y here equals to the 4.1, and the second value 2.01, y here equals to the 4.01, and here 2.0001, and the value of y here equals to the 4.0001. Yeah, and this function is approaching 4 from the right of the function. So write down the limits as x approaches 2 of fx, x squared minus 4 over x minus 2, and here equals to the 4. Yeah, okay, so limit here approaching the same value from the both sides of the function. From the left here equals to 4, and from the right here equals to 4. Yeah, and conclusion, limit here exists. Limit as x approaches 2 of x squared minus 4 over x minus 2, and equals to 4.